This is the brief on the Vector Laplacian Identity. So this crucial equation, you can basically think of it as a super useful shortcut in physics and engineering. It proves that this really complex idea of a double rotation in a vector field, like fluid flow, can actually be split into two way simpler parts: the field's expansion and its overall curvature. All right, first up, the formal proof is in the source material, yeah? But what you really need to get is how this identity mathematically separates different kinds of energy in the field. It confirms that the energy driving rotation, that's what we call the curl, is totally separate from the energy that causes stretching or squishing, which is the divergence. And, well, that makes modeling complex fluids so much easier. Second, this identity is great for isolating specific effects. So imagine a field controlled by just two variables. Let's call them A and B. You see this really clean split. Parameter A, it only controls the divergence, that stretching component. Meanwhile, parameter B is all about the field's curvature. And that separation is huge because it makes troubleshooting or just tweaking the system way, way simpler. And finally, let's look at what the vector Laplacian itself tells us. See, the curl measures rotation at specific spots, and that can change all over the place. But the vector Laplacian, that gives you the total curvature of the whole field. So when we zero in on that term controlled by parameter B, we find that B is solely responsible for creating a uniform curvature across the entire system. So really, the vector Laplacian identity is this incredibly powerful tool that lets us dissect complex field movements into simple, predictable parts: rotation, stretching, and curvature.